All right, guys, so what we talked about yesterday is we talked about the function y equals a times bx minus h squared plus k, where the vertex is the point h comma k, and the axis of symmetry is the line x is equal to h. Now we also talked about the equation, the standard form, y equals ax squared plus bx plus c, where the vertex is the point negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry is x is equal to negative b over 2a. So we have standard form, and we also had vertex form. Now we started, well, we got pretty much all the way through this problem here, yes? Because this problem here yesterday we talked about the fact that this is a minimum, and the minimum value for this function was, I remember from yesterday? Negative 3. Describe the domain. The domain was all real numbers. The range was y is negative 3. Now, increasing and decreasing is where we stopped, I believe. I think we wrote it down. I might have been talking about it right as the bell was ringing. So decreasing was our negative infinity comma blank. Increasing is going to be what we'll also see. Now, increasing, so decreasing to the left of x is equal to negative b over 2a, increasing to the right of this here. So this here will probably not match up exactly as the textbook has it, but I like interval notation a little bit better. Alpha. Y equals alpha y equals 1/2 x squared. I'm just trying to pull the function back up for us, minus 2x minus 1. So we graphed this yesterday, and we're looking at its graph. Yes? Okay. Yeah, we're going to do this a little differently than them. Now, we noticed at the vertex, when it's coming down this way, it is decreasing as we read it from left to right until it hits this point here, where x is 2. Because at the point when x is 2, it stops decreasing and starts increasing. So it is decreasing from negative infinity to 2, and it's increasing on the range from 2 to infinity. But when we just look at the graph, we can see it is decreasing, it's going down all the way to 2, and then from 2 to infinity, it is increasing. Questions on this here? We good with this here? Now, specifically, if we're talking about increasing and decreasing, by definition, a function is decreasing. Do not write this down. It really doesn't matter. Decreasing if x1 is, see here, is less than x2, and f of x1 is greater than f of x2. This is just by definition decreasing. Because if I'm given 2 points, I'll pull the graph back up. So 2 points on this graph. Come on, there we go. I'll just pick this point here and this point here. So -3 and -1. Is -3 less than -1? Well, yes, -3 is smaller than -1. So that part is true, yes? Now, f of -3, the y value is up here, f of -1 is down here, yes? But is f of x1 greater than f of x2? So f of x1 would be the y value of -3. Is that one bigger than the y value at -1? Well, look at this. So -3's y value is where? At -1 it is. So if this is our x1, the f of x1 is up here. If this is x2, f of x2 is down here. So as the x values increase, the y values are, so this is by definition decreasing. Increasing would be very similar, because we would still say x1 is less than x2, and f of x1 is less than f of x2. Just notation-wise, as x increases from left to right, is the function's y values going down, or are they going up? And that's just the mathematical notation for it. But if we look at a graph, is it going down, or is it going up? Is all we're looking at for increasing or decreasing. Okay? And that's really it for that there. Let's look at another one. Okay. Well, let's utilize the graphing calculator to do this for us. Clear all that out. Clear. So let's start off by hitting y equals. So we want to put our new function in, yes? Now we could go through and type through, but I'm going to just go on and hit clear to clear the old function out. We could say negative x squared plus 5x plus 9. And once you get that typed in, go on and hit graph. So that one there will square it. You can also hit the button above the division key, that little caret, because it will put it up into the exponent, and then you can hit 2 to square it. So for really anything greater than 2, we can use the little caret key. I call it a caret key because it looks like a little caret or a little tent. Hit it, and then it'll do exponents for you. So let's go and hit graph. Well, the vertex is not shown. It's up above the graph, yes? But we know that this will be a maximum or minimum value. Maximum, because the graph is opening down. So it will be a maximum value. Well, we could go and do this by hand if we want and find the negative b over 2a to find the x value and then find the corresponding y value. But we do know it's a maximum, yes? Why don't we let the calculator do it and calculate this for us so we can go second trace. And what do we want? Maximum, yes? Now, there's two ways we can get it. The main way I've shown is we scroll down to where it's highlighted and hit enter. What's the number in front of maximum? 4. Try hitting 4. It's a shortcut. Those will automatically get it for us. So we want to find the maximum value. Now, left bound, as we talked about yesterday, we want to point to the left of the maximum value. Yes? Are we to the left of it? Yeah, the little X is right up there at the top. We are at the left of the maximum point. So we can go on and hit enter. But we're definitely not at the right of that value, are we? No. So we're going to hit the right arrow. Well, I'm definitely to the right of it. Because if you notice when you were clicking right, because the value for y went up, it was at 13, went to 14, went to 15, went to 16, then went back to 14, 13, 12. It's coming back down. So we could be good here. But if we want to, I can keep clicking it until it shows back up and hit enter. Now, for some graphs, this might be a little, we would want to be a little bit more cautious because there are chances that it can kern more than once. We can have more than one maximum and minimum values. And we'll cover those when we start talking about higher degree polynomials. But here, it's a U shape. It only has one max and one min. There's only one spot. Now it's wanting us to guess. It wants to give us a guess, but I'm good. I would say 2.5. And the y value is 15.25. Did y'all get the same numbers? So the maximum value is 15.25. What's the domain going to be? All real numbers. Because again, since we're still dealing with the quadratic, the domain will be all real numbers. The range is going to be what? So range is, y is it going to be less than or equal to or greater than or equal to? Which way are we going, up or down? Down, so all the values should be less than or equal to 15.25, because it should be all the points lower than that. Yes?
What step did I miss to get no idea?
One more.
Oh, okay.
Yeah, so when we do the maximum, minimum intersections, any of those, it'll ask one for left bound, one for right bound, one for the left of whatever we're looking for, one to the right. Once we do that, it says guess. So it gives you an idea to guess what you think it might be, but we normally don't guess. We just go on and say, just tell me. Because if I was guessing, I already knew it, I wouldn't be plugging it in anyway. So we hit enter one more time after guess, and it'll give it to us. Now, a lot of the times, 2.4999987, it's approximating for the pixel size of the screen. So it's sometimes not 100% accurate when it does this. Because if we have a long decimal, it'll still work out just fine. Now, 2.5 is our x value, yes? So it is increasing from negative infinity, coming from the left side, because it is coming up, to 2.5. And it is decreasing from 2.5, comma, infinity. It's going down. And the point 2.5 is what we would call a turning point. Because what is it doing at 2.5? It's going from decreasing to increasing, or the other one, it was going from increasing to, this was increasing to decreasing, or decreasing to increasing. It is turning, essentially, yes? So they call it a turning point. If we do have time, and I remember at the end of the hour, I will show you this here in 3 dimensions. In a 3-dimensional turning point of 2 functions, 2 quadratics, they actually call it a saddle point. Because if you've ever ridden on a horse or ridden on anything, a saddle is literally what it looks like. Questions on this here? We feel good with this here? I realized partway through that there were actually 2 questions on that, A and B. I don't know if y'all noticed that. F of x equals 4x squared plus 16 minus 3. And then B, and I just skipped A, I didn't even see it. And we have this here. Now, I just want to go on and show you this here, that this is going to be our 2.5, I believe is what it was, for the x value. So if we have this here, we would have negative 5 over 2 times negative 1, which would be negative 5 over negative 2, which would be 5/2, which is exactly 2.5. So that is the exact value. So sometimes with the calculator, or with using the graphing function, there is a little bit of a rounding error that occurs. Or pixel error, I think is actually the more correct way to say it. Questions on this here? We feel comfortable with this? Let's look at the last type. Properties of the graph f of x equals a times x minus p times x minus q. Because f of p is equal to 0 and f of q is equal to 0, and p and q are the x-intercepts of the graph of the function. So this is our intercept form. So those are where the graph crosses the x-axis. As we said, they are the exact same distance from the line of reflection. So if I want the axis of symmetry, really I can take p plus q and divide by 2. So our x is going to equal p plus q divided by 2. And that really means our vertex is just going to be the point p plus q divided by 2, comma, f of p plus q divided by 2. Because again, the x, or the axis of symmetry, what it's equal to is the x value of the vertex. A is greater than 0, it opens up. A is less than 0, it opens down. So let's go on and look at this here. Graph the function. Well, we're not going to graph it. Label the x-intercepts, or we're going to name the x-intercepts. Now the x-intercepts are going to be p comma 0, q comma 0. Because when they intersect the x-axis, the value of y is always 0. So looking at this here, where are p and q? They're inside the parentheses, yes? So what would the value of p be? Almost. And q is positive 1. Because when we look back at the formula, it's a times what? X minus p times x minus q. And p and q are really interchangeable. They're just those 2 points. But we are subtracting them. So that means if inside the parentheses the value of either one of them is positive, it means the actual value is negative. And if the value in there shows up as negative, it's actually positive. Well, we'll find the vertex next. And the axis of symmetry. I just need to get rid of that eventually. Okay. Now, to find the axis of symmetries, x equals, or the x value of the vertex, we need to do what? Take p plus q and divide by, well, we said p and q are negative 3 and, well, negative 3 plus 1 is, over 2 is, so the x value of the vertex is negative 1. The axis of symmetry is that x equals negative 1. Well, to find the y value, we just need to plug negative 1 back in. So we have negative 2 parentheses, negative 1 plus 3, close parentheses, open parentheses, negative 1 minus negative 1 minus 1. Well, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Well, we have a negative times a positive times a negative, so this whole thing will be positive. 2 times 2 is? So the vertex is at negative 1, 8. The axis of symmetry is x is equal to negative 1. And our x-intercepts are at the points negative 3, 0 and 1, 0. So the x-intercepts are at negative 3, 0 and 1, 0. The vertex is at negative 1, 8. And the axis of symmetry is at x equals negative 1. And that's it. Now if we pull the graphing calculator up, y equals negative 2, parentheses, x plus 3, close parentheses, open parentheses, x minus 1. Okay. I forgot I left all that on there, but we can do that there. Sometimes if you have stuff after it, you can hit clear once, and it won't clear everything. It'll just clear everything after that. But you need to be careful because sometimes it will clear the whole thing. But we get this function typed in, and we can go on and hit graph. There are our 2 intercepts at 0, yes? We can go second table and look at this here and see. We have our 2 points where the graph is at 0, yes?
Chloe thought, come
Okay. So we do have negative 3, 0, and 1, 0 as our two x-intercepts. Negative 1, 8 is our vertex, because again, we can see that it is in the exact between those 2 points. And we also have verified that the axis of symmetry is at x is equal to negative 1. That's it. Questions on this here? Let's look at the next one and see if we can look at it on the graph as well. Now we can say negative alpha y equals enter. I'm just plugging in the negative 1/3 parentheses x minus 4 close parentheses open parentheses x plus 2. And once we get that plugged in, we can go on and hit graph. Well, we can see the graph opens down, and we can kind of see those two intercepts are at whole numbers. Yes? Well, where are they at? So we have negative 2, 0, and at. And this point about right here would be the axis of symmetry, or it would be the axis of symmetry and where the vertex are located. To get a better idea, we can go second table. So I need to scroll down. Okay, so negative 2, 0, we have confirmed that that is one of the x-intercepts, yes? Okay, 3 looks interesting. And we've also confirmed that 4, 0 is the other intercept, yes? So our two x-intercepts for this here, as we said, negative 2, 0, and at 4, 0. Where do we think the vertex is at? I think 1. Because we can check it and say negative 2 plus 4 is, what's negative 2 plus 4? 2. 2 divided by 2 is 1. Because our P and Q are negative 2 plus 4 divided by 2. Well, negative 2 plus 4 is 2, and 2 divided by 2 is. So the vertex would be 1, 3. The axis of symmetry would be x is equal to 1. So if we come back here on this here, we figured out x-intercept is negative 2, 0, and 4, 0. Vertex we saw was 1, 3. And the axis of symmetry is x is equal to 1. Besides graphing, did we answer everything? Yeah, that's all we need to do. Any other questions on this here? Because all we have is this one and the one after it. Is there one of those two that you would like to look at, or do y'all feel comfortable with this here? We're good with this here? All right. that is it for today. Now, just as a reminder, you do not have to graph any of these here. You do not have to graph them. I'm not asking you to graph them. I just want the other information. So on the ones that we did first yesterday, just really getting the axis of symmetry and the vertex. The next set, when we talked about in standard form, the vertex and the axis of symmetry are the other parts. You do not have to graph them.